So for homework number 7, number 8, number 9, 7 and 8, you have the vertex form given to you. And you need to find all the other pieces, and we'll go over one of those, 7 or 8 together, and I'll have you do the other one on your own. And then 9 is given in standard form. Here's 10, 11, and 12. Each of these are given in standard form. And these get to a little more challenging types of factoring problems, but things that we need to know how to do. And they also end up giving you x-intercepts that are fractions. You'll look at how to handle those when you get x-intercepts that are fractions. Okay. And we'll do at least one of these together today as well. And then the last part of the homework, I give you a vertex and a point. And that's it. And we gotta, from that point, we gotta find everything else. And it's not too tough to get the vertex form. Kind of did that on the board already. But finding things like x-intercepts or getting it in factored form, a little more challenging. At least at first, it might feel a little more challenging. Again, I'll do one of these with you for sure, and have you do the other one now. All right, so we have 3 forms of an equation. We're going to do number 11. The factored form, remember we said the B and the C in the factored form really should probably be a different letter. Maybe E and F, or just because those don't correspond with the B and the C in the standard form. Also, I want to make a note, in the factored form, the A, you could write factored form in that form, but factored form could also look different. It doesn't have to fit the form that I have here. And you'll see that on number 11 when I do it, and I'll point it out to you. But the vertex form, that A always will correspond with the A on the standard form. Okay? So if you're given standard form, you're first going to try to get factored form. And right now, everything's going to factor for you. Eventually, I'm going to give you stuff that won't factor. And I'll have to give you a new technique and try to figure out what to do. We're not there yet, though. But right now, we're working on the factoring part. Okay. So we're looking for 2 numbers whose product is 9 times -7, which is -63, and whose sum is -18. Okay, I'm going to pause. I want you to go ahead and try to factor that. Or finish it if you can. Okay. So -21 and 3. Did anybody have trouble finding this? Everybody's good with that? Okay. So then, after you find those numbers, you're going to rewrite this as y equals 9x squared minus 21x plus 3x minus 7. And then you factor by grouping. You group the left half, the 9x squared and the -21x, and factor out the GCF, or the greatest common factor from both those, which is, and we're left with, and then you factor out the GCF of the right half, which is 1. And both have a 3x minus 7. And so we get factor the 3x minus 7 out, and we're left with what? 3x plus 1. And that's our factored form. Okay. Now, from standard form, we can get our y-intercept, or actually any form you can get a y-intercept. You plug in 0 for x and you find it, right? On the board earlier, we found our y-intercept from vertex form. Okay. But it's easy to find it from standard form, because if I plug a 0 in for x, what do I get? It's negative 7. So just going to note that here. Y-intercept is going to be, plug in 0 for x, you're going to get negative 7. Try that out and you'll find that. For the x-intercepts, we're going to set y equal to 0. And so we get this equation. 0 is equal to some number times another number. And x is a variable which we could plug something in there. So if you have 0 equal to a product of two numbers, one of those numbers has to be 0, right? So it's either this one could be 0 or this one could equal 0. And so then we're going to figure out, well, what x value would make your first factor 0? And what x value would make your second factor 0? And those end up being our x-intercepts. So in the first one, we end up with 7/3. The second one, we end up with negative 1/3. And so our x-intercepts are going to be 7/3, comma 0, and negative 1/3, comma 0. Now I want you to notice that our factored form is not the factored form up here. Okay? And just to show you that, well, what's a in our equation? 9. Okay? Then you go ahead and look at factored form. Do we have that in the factored form? No. But there is a factored form, and I'll write it right now. This is the same thing. If I put a 9, I'm going to have x minus 7/3 and x plus 1/3, which is an interesting factored form because you see the x-intercepts and you see a. These are the exact same thing. And the way you go from here to here is you'd have to split this up to 3 times 3. Take one of the 3's, multiply it with your first factor. Take the other 3, multiply it with your second factor, and you end up here. You don't have to do that, but I'm showing you that there does exist a factored form with a 9 out in front. Okay. So we got our x-intercepts, we got our y-intercepts. And once you have your x-intercepts, you could find your vertex. How? If I give you any two x-intercepts, you can always find a vertex. You know, if these are my x-intercepts, where's the vertex in relation? It's in the middle, right? I don't know how high high or how low, but I know it's right in between my x-intercepts. So if we have our x-intercepts, so if we can find the middle of two fractions, yeah, I know, we could do it. We can find the middle of the two fractions, we can find the vertex. So if I give you any two numbers, how do you find the middle of those two numbers? Not multiply them together. Add them together. Yeah, it's called averaging, right? So if we average our x-intercepts, we find the x value of our vertex. So I'm going to let you think about what that average is. And before I average them, I'm going to sketch in my graph here what we do have. Sometimes it's helpful to interact with your graph and just get an idea where things are. So I have a y-intercept at -7. There. I have an x-intercept at -1/3. Where would I put that? Yep, -1/3 between 0 and -1. I don't care where you put it in between, as long as it's in between 0 and -1. Okay? And then 7/3, where would that be? Between what and what? 2 and 3. Right there. So we want to find the middle between those two x-intercepts. Kind of ignore the y-intercept right now, because that's definitely not the middle. Okay? So some of you are saying the middle's 1. And here's how you find the middle. So the average is 7/3 plus -1/3 divided by 2. Okay, and so when I add those up, I get 6/3 divided by 2, which is 2 divided by 2, which is 1. So I found the middle of my graph. I'm going to draw the middle, which we call the axis of symmetry. But today it has another name. Anybody know the other name besides the axis of symmetry? The line of symmetry. Sometimes we call it an axis, sometimes we call it a line. It's both. But just so you don't forget, I'm going to write line of symmetry today. What's the equation of our line of symmetry? And that's another piece that we need to find. Okay. So for our vertex, we just found a piece of our vertex, right? Not everything, but we found our x value of our vertex, because the vertex is always in the middle. It's always on the axis or the line of symmetry. So we found it's 1, comma, and we got to figure out what the y value is. But if you know an x value, you can always find a y value. How? Plug it in, right? Plug it into which equation? It doesn't matter. It's the same equation, just in a different form. So pick the form that you want, plug a 1 in, and find out what y is. So I'll pick the first one. If I plug a 1 in here, I get 9 times 1 squared minus 18 times 1 minus 7. And I get -16. So that's a bit off my graph. And so I'm just going to write the point 1, -16. And so when I sketch this, something like that. So in my graph now I have 4 points. There is a fifth point that's really easy to get. Can you see the fifth point? Which one? So what would it be? 2, -7, right? Because there's symmetry. So if I'm 1 to the left of my middle, I'm at a height of 7 or -7. So if I go 1 to the right of my middle or axis of symmetry, I'm going to be at the same height. Okay. And when I want you to make a table, I want you to get 5 points, and we have 5 points already graphed, so might as well just put those in. Oops, sorry, my first point, and you could use fractions, it's fine with me. The first point we have is, going from left to right, is -1/3, 0, 0, 7, 1, -16, 2, 7, sorry, -7, huh? And 7/3, 0. Those are the 5 points on the graph. So we only need one more thing. We need our vertex, and then maybe talk about the domain, range, increasing, decreasing. So our vertex form is going to be what? Y equals 9, because that's our A, x minus 1 squared minus 16. Okay. Now, we've been finding some key things along the way, and I've been highlighting them. And so the things I've highlighted already, usually we write next to the graph, but I'll give you the option. If you have a highlighter, you can highlight them there. You don't have to write them again. If you don't have a highlighter, then I want you to write them again. Okay? And so all we need to do is to list what we haven't done. So what's our domain? All real numbers. What's our range? Greater than or equal to -16. Where is it increasing? Which side, I guess? Increasing when x is greater than or less than? Greater than or equal to what? 1, the middle. And it's decreasing on the other side. Okay. And now we found everything we need to find. So yes, it's a big problem. Yes, there's lots of pieces there, but hopefully you're seeing how they interact, they can, the connections between them. Questions on this one before we leave it? Yeah. You plug in 0 into any equation. I plugged in 0 here, and wherever there's an x, it disappears, and so I get -7. But if you do it here, you'll get it as well. You'll get 7 times 1, which is -7 times 1, which is -7. Any other questions? All right, then let's go back to number 7. Let's do number 7 together. So 7, now we start with vertex form. We got to find all the other pieces. If it helps, you can also write this as -3 in parentheses x minus 0 squared plus 12. It's the same thing. X minus 0 is the same as x. But by writing it that way, it may be helpful to you to see what the vertex is. What is that vertex? Good. All right. Then from there, we want to find our standard form. And the way you find your standard form is you multiply everything out. But there's nothing to multiply out here. Yeah. Well, it's 12 being squared. You see what I'm saying? So, so here's what you do. Put parentheses are only around what's being squared. And I'm going to do that right here. X is the only thing that's being squared. And so I know the 12's not in there. Now, if you look at the one below it, it's already set up for you, right? 3's in there. And if we're going to standard form, on number 8, you're going to have to multiply. You have to figure out what x plus 3 times x plus 3 is first, and then multiply that by 2, and then subtract 8. Little bit of work to get to the standard form. But here, it's already done for us, and so we just copy. It's the vertex form is the standard form in this case. And if you want, you could even write it this way. I'll write above it. So you could see that B's non-existent. It's 0. That's why we don't have an x in the middle of it, right? So usually we don't write 0x. We just leave it out. But you could write that, and then you can see, oh, A is -3, B is 0, and C is 12. Okay. To get to factored form, we're going to have to factor. And when you factor, the first thing you want to always look for is, can you divide all your terms by something? And here we can use 3 or -3. Which one am I going to pick? Good, because I want a positive leading coefficient. So I'm going to factor the -3 out. And I'm left with x squared, what? +4 or -4? And that's good news, because x squared and 4 are both perfect squares, and if you have a minus sign between them, we can factor this pretty easily. You take the square root of each one, so you get x and 2, and one's going to be x plus 2, one's going to be x minus 2, and it's factored. So if you compare all three forms have an a of -3 in this case. So the factored form actually worked out nicely for us here. What's our y-intercept going to be? Plug in 0 for x. What do we get for y? 12. Let's find our x-intercepts. Let's set y equal to 0. And this time we have 3 factors. So this is like me saying, hey, 0 is equal to -3 times something else, right? And so we're trying to figure out what x value is going to make this equal to 0. Well, if the x plus 2 equals 0, then it works out. What x value is going to work there? -2. What about this one? +2. And those are going to end up being our x-intercepts. Okay, so x plus 2 will be 0 when x is -2. X minus 2 will equal 0 when x is +2. And so we get -2, 0, +2, 0. Don't worry about what? Yeah, the 3 is not gonna, you can't plug x into 3, right? And so that's not gonna, it doesn't have an effect on the x-intercepts. So you ignore that. You only work with the factors that have variables in them. Okay. All right, so let's graph what we have. The y-intercept way up here at 12, got 2 x-intercepts, -2 and +2. Do we always have to have 2 x-intercepts? Is it possible to have a parabola that doesn't have any x-intercepts? What if I had a parabola that did this? Would it ever cross the x-axis? So it wouldn't have x-intercepts. Will a parabola never have a y-intercept? It will always have a y-intercept if it's opening up or down. If it opens sideways, it's a different story, but we're not going to get to this. Just know that eventually I'll give you those. Right now, every parabola I'm going to give you will have 2 x-intercepts, but eventually I'm going to start changing that up on you too. Okay. So we got 2. Anybody know what's going to happen? Like if it has no x-intercepts, solve for the x-intercepts. Anybody have an idea what might happen? So we're going to get imaginary answers. And so we're going to be talking about imaginary numbers in this unit as well. Okay, not yet though. All right, so here we have. It turned out that our y-intercept is our vertex, and we have 3 points. For our table, I want 5 points. So you have some freedom to pick the other 2. I'm going to do 1 and -1. Are 1 and -1 going to have the same y value? Yeah. What is it going to be? Nine. Okay. All right, so we're pretty much done with this one. Our domain is all real numbers. What's the range? Y is less than or equal to 12. Increasing when x is, which side? The right side or left side? So when x is less than or equal to what? 0, right? Because it's the middle. -2, what'd you get? Oh, no, you want to go all the way to the vertex. So when x is 0, go all the way to the middle. Decreasing when x is what? Greater than or equal to 0. What am I forgetting? Line of symmetry or axis of symmetry. Good. So I'm going to put that in too. I'll put that on the where the graph is. What's the line of symmetry? X equals 0. Is our vertex a maximum or a minimum? Good. The highest point, so it's a maximum. All right, so I'm going to now stop, and I'm going to let you work on some problems. Don't work on the last two problems. Don't work on 13 and 14 yet. Work on some of the other ones, and I'll be around just to allow you to ask some questions, okay? I want you guys working hard right now, though, okay? Yes, you'll be getting homework done, but also, if you get stuck, you're at a place where you can get those questions answered. So on number 13, we're given the vertex, and we're given a point. And we need to find all the other pieces. Where do you think we start? Okay, yeah, we could totally find that other point. Let's find it. Might as well. All right. So we know this is cut down the middle. So we can get the axis of symmetry pretty easily, right? What's the axis of symmetry going to be? So x equals -3. um, and then how far is this point, this -7, 18, how far is that from our axis of symmetry? It's 4 to the left, right? So if we go 4 to the right of -3, where will we be? At 1. So this point's going to be 1, 18. So yeah, we automatically get that point for free. That's good. All right, what else can we do? We're making some progress. Okay, we can work on vertex form. And here's what we write. I'm going to make a mistake. You tell me what my mistake is. Yep, good. I have no idea what A is, right? So I need to keep the A there until I know what it is. But that's how we start. And to find A, we just need another point. And we got 2 other points. The vertex only helps us with H and K. I could use 118, or I could use -718, or some other point if I knew another one. You guys want to use 118? Okay, no, avoid the negatives. That's fine. So I'm going to plug in 1 for x and 18 for y. So I'm going to pause here, see if you could solve for a. I want to make sure you guys have the right mechanics to solve for a in this equation here. All right, so I gave you guys a head start. I haven't seen the right answer yet, but I didn't look at everybody's page yet. So I'm gonna first add the 1 and the 3. And 4 squared is 16. And you might be tempted, but do not subtract 6 from 16. Because 16 is multiplied with the a first. An order of operations says you have to multiply before you subtract. But we don't know what a is, so we can't multiply, so then we can't subtract. Okay? So instead, add 6 to both sides. And then divide by 16. And then reduce, and you get 3/2. Did you get that? Okay, good. So if you didn't, you want to work on some of your mechanics for solving. Okay, try to figure out what went wrong. Careful with the order of operations, okay? So our vertex form, I ran out of room here. I'm going to write it above, is y equals 3/2 x plus 3 squared minus 6. Okay. What can we get from that vertex form besides the vertex? We already have the vertex. Okay, we can get standard form by multiplying it out. But that 3/2, I don't know, might be a little ugly to multiply that out for standard form. So what else could I get? Can I get the, can I get a y-intercept? Sure. How do you find a y-intercept? Plug in x, plug in 0 for x. Can I get an x-intercept from this one? We haven't done it before, but can I? Sure. How do you find an x-intercept? Plug in 0 for y and solve. So I'm going to do this a little differently, just again to show you some other ways, and this probably is an easier way to go about finding factored form. I'm going to find the x-intercepts now, and I'm going to do it under the factored form because there's space here, and it's going to help me find factored form. So for my x-intercepts, I'm going to let y equal 0. So 0 is 3 over 2 times x plus 3 squared minus 6. And now we need to solve again. This is not factored, so you can't set the factors equal to 0 and solve. You actually have to do something like we did for a and solve it. What would you do first? Add 6 to both sides. Actually, leave it. Don't get rid of the x plus 3 squared. We like it like that, and I'll show you why. It's very helpful to keep it like that. So I'm going to add 6 to both sides. And I want to keep that x plus 3 squared, but I want to get rid of the 3 over 2. Multiply by 2. I'll do multiply by 2 first, and then I'll divide by 3. But you could do the other one. You could do it in one step. But we want to get here. What's my next step going to be? What's that? Take the square root of both sides, because then I get rid of the square. And when I take the square root, I get positive or negative 2 is equal to x plus 3. You know why I have to put positive or negative? Because if you square negative 2, you still get a positive 4, right? So that gives me two equations. I'm going to separate them. I get x plus 3 equals positive 2, and the other one is x plus 3 is negative 2, which gives me two x values. And I found my x-intercepts. So you don't have to use factored form to find x-intercepts. You could use vertex form. Okay? Now, here's the nice thing. I can write my factored form of my equation now. I'm going to do it, see if you can tell where things are coming from. There we go. So, if you don't see it, I'll help you. See where I'm getting the 3 over 2 from? That's A. Okay. How am I getting x plus 1? Well, I know my x-intercept's -1, so I'm working backwards. Remember you had, when it's factored and you had to find your x-intercept? You'd set this equal to 0 and solve, and you get x equals -1. So I'm thinking backwards. I'm saying, well, if x is -1, then this would have to be x plus 1. If x is -5, this would have to be x plus 5. And now I have my equation. You can do that. Again, we're still making some of these connections. Standard form, we have to multiply something out, but you get to choose. Does it look easier to multiply the vertex form out or the factored form out? Factored form looks a little easier. I'm going to do that one. So I'm going to leave the 3/2 alone until the very end. I'm going to multiply the x plus 1 times the x plus 5 first. And so my answer needs to stay in parentheses with the 3/2 on the outside. And then for the last step, I'm going to multiply by the 3/2. And I can reduce the 18 over 2. So my standard form would be 3/2 x squared plus 9x plus 15 over 2. And you can see, if we went to standard form first and had to factor that, that'd be pretty ugly, right? So sometimes it's nice going from vertex form to factored form. What's my y-intercept? Standard form's the easiest one for this one. 0, 15 over 2. So, oops. I'm going to have you finish this one, but we've done a lot of it together. We found the y-intercept, found our x-intercepts, found our we had the vertex, got our axis of symmetry, and so 14 is going to be just like this one. And give it a try. Do the best you can on it, okay? So I'm going to stop there, and homework is to finish 7 through 14.